आवाज येतोय?
Yes, sir.
राईट. Okay. Module number 5, cables and suspension bridges. Okay, please write down. Screen is visible. Screen is visible.
Yes, sir.
Right. Okay, module number 5, cables and suspension bridges. Okay, heading दिलात का?
Oh, sir.
So now first we will discuss what are the components of the suspension bridge. Then we will discuss about the structural part. Okay, so now you can draw this. Okay, in case of cables and suspension bridges. Okay, this is your suspension cable. This is suspension cable. Okay, this is the main. Okay, suspension cable is the main load carrying member. Okay, in case of suspension bridge, it is a main load carrying element. Okay, this is your supporting tower. Please draw this diagram. Supporting tower, or you may call as pylon. Okay, this is the suspension cable and this is called as a anchor cable. Okay, suspension cable is the main load carrying element. Okay, for that supporting tower and pylon, and this for anchoring cable. This is your roadway or roadway or road. This is called as a deck slab. Layout under deck slab will be transmitted to the cable, and that will be transported to the cables. That vertical cables are called as a suspenders. Or you may call as hangers. Load on deck slab. Okay, so whatever the load on this deck slab, that will be transferred through the suspenders. That will be transferred to the suspenders, or you may call as hangers. You may call as hangers. Okay. Okay. So whatever the suspension cables are there, that will take the entire load. Okay. So whatever the load on this road, this is called as a road. Whatever the loads, okay, on the deck slab or on the road, that will be transferred to the suspension cable, that will be transferred to the suspension cable through the suspenders or through the hangers. Suspenders are placed at a suitable spacing, and that will be transferred the load to the suspension cable, right? This is also called as anchor cable. As I told, suspenders or the hangers are closely spaced. Okay, if you see this deck slab at the bottom and there is a curve, their suspenders are placed at a suitable spacing. So it nothing but the load is in nothing but in terms of the UDL. The load is in terms of the UDL on that particular road, right? Please draw this diagram. This is huge mass of concrete. The anchor cables are connected to huge mass of concrete. Or it is also called as a raft foundation. Diagram is over. Diagram is over.
Just a minute, sir. एक मिनट sir.
Okay.
Done, sir.
Okay. Suspension cables are made up of flexible material, and suspension cables are only carry the tension. because cable is a tension member. If you are discussing the tension member, so in case of tension member, one of the type of member of carrying the tension, that is called as a cable. So cable is purely tension member. Cable is nothing but it is a purely tension member. So we will design this cable as a tension member. We will design this as cable as a tension member. Okay. So direct tension T is equal to whatever the stress that multiply by the area, right? So direct tension T is nothing but the whatever the stress in that particular cable multiply by the area of the cable, you get the tension in that particular cable, right? So now we will discuss the again what are the elements of the suspension bridge. Wait. If it is visible,
Yes.
right? So suspension bridges. So suspension bridges is the type of bridge which is built by suspending roadway, okay, from the cables. As you can see in the diagram, this is suspension cable, this is nothing but the deck slab, and these verticals are called as the suspenders, okay, which is built by the suspending the roadway from the cables attached to the master cable, okay, master cable, suspension cable, which runs above the length of the bridge or the road, okay, and they are strong and the lightweight. Suspension bridges are the strong and the lightweight, right? So these are the elements of the suspension or the components of the suspension bridges. First is the main cable. First is nothing but the main cable, okay, the cable that runs along the top of the bridge and is anchor at the ends, right? That is called as a anchor cables, right? This cable has also once built, okay, magnetic chains until it was found in cable made up of thousands of steel wire would be much as a stronger, okay. Then next is the suspender cables. These cables are also made of similar to the main cables. However, they are not the thick. These cables help to suspend the deck and are moderately made up from the steels, right? That is suspender, vertical cables. Then the deck slab. The deck is the main area of the bridges where where the vehicles and the people travel. That is called as a deck slab, right? This part of bridge is made up of multiple steel trusses and is the span of the bridge. Then the tower, that is vertical supports. Okay, the towers are where the cables attach to create the perfect parabolic shape with the next tower in order to create the strongest hold, right? So vertical towers are there. त्याच्यावरती तुमचे cables round होत आहेत. One end is hinge, other is your roller support, right? Like that. This anchor cable, this is suspension cables. These are nothing but the towers. Okay, then tower foundation. It is a part of the tower rest, that is nothing but the raft or the made up of the concrete. This can be either on the ground or even below the water. Okay, below the water foundation require a lot more time and the effort. And anchors where the main cables attach at the end of the bridges, right? And the anchors can be created with the rock, or if there is no strong enough rock, the foundation can be made up of the concrete. So these are nothing but your components of the, again, suspension bridges, suspender cables, main cable or suspension cable, the vertical that is called as towers, main cable, deck slab, main cable anchorage. Okay, and this is a tower foundation. So we have to design the cable. Okay, what is the shape of cable, what is the length of the cable, etc. That we have to consider. Okay, this is again the main components of suspension bridges. Pylon or the tower, then anchorage, suspenders, and the main cable or the suspension cable. Wait. One minute. Okay. Now, nowadays, these are the pioneers in the bridge technology, that is suspension bridge. If you can see the Bandra Worli ceiling bridge in Mumbai, okay, that is suspension bridge. So of all the bridge type which is used today, the suspension bridges allows for the longest span, okay, ranging from 2000 to 7000 feet, right? That is allows the longest span. So this type of bridge has the cables suspenders between towers, and the cables support the vertical suspender cables, right? This type of bridge has the cable suspended between towers, and the cable support vertical suspender cables that carry the weight of the deck below. Okay, so whatever the deck slab is there, suspenders are there, they are connected to the suspension cable. Suspension cables are passing through the towers, right? Passing through the towers, and on another side it will anchor. Okay, so carry the weight of the deck below. So whatever the load on this, that will be transferred through the suspenders to the suspension cable. Okay, whatever the load on the deck slab, okay, due to the vehicle moving, etc., that will carry by the suspenders, and suspenders will transfer the load to the suspension cable. This arrangement allows the deck to be level, okay, or to arc upward for additional clearance. The suspension cables are anchored at each end of the bridge. Okay, the suspension cables are anchored at each end of the bridge, and they are ideal for covering busy waterways. So this is general about the suspension bridges. So again the terms, more terms. Side span, this is your side span. The segment between two pylons, pylons is nothing but the vertical supports, towers. Okay, segment between the two pylons at the ends of the bridge, that is nothing but the side span. Then center span, okay, this is called a center span. the segment between two pylons or the two towers at the center of the bridge is called as a center span. Is called as a center span. The next is a side pylon. Okay, at the end of the bridge, this is called as a side pylon. Okay, so towers like vertical construction. Okay, towers like a vertical construction situated at the side and which is usually supporting the cables of the suspension bridges. So this is called as your anchor cables. This is called as your anchor cables, right? So tower like vertical construction at the side usually supporting the cables of the suspension bridges, that is called as a side pylon or the side tower. Next is the foundation of the pylon. Okay, so very durable lower part of the tower. Okay, this is called as a foundation. This is called as the foundation of the pylon or the foundation of tower. Okay, very durable lower part of the tower. Okay, next is the suspenders. Okay, so whatever the vertical cables are there which are connected to the deck slab and the suspension cable which will transport the load from deck slab to the suspension cable, that is called as a suspender. That is called as suspender, which is also called as a supporting cable, which is also called as supporting cable. Next is a suspension cable. Okay, suspension cable. This is your suspension cable. The set of braided wire that supports the bridge, that is called as a suspension cable. The next is a pylon or the tower. Tower like vertical support. This is vertical support that usually supports the cables of the suspension bridge or the cable stayed bridge. The tower which is like vertical support that usually supports the cables of a suspension bridge or the in case of the cable stayed bridge. And last is a stiffening girder. Okay, last is called as a stiffening girder. So girder is nothing but the one of the type of the beam, but the span is more compared to the beam. Okay, so for giving the stiffness to the pylon, we are providing additional member that is called as a girder, and that girder is called as a stiffening girder. That girder is called as a stiffening girder. That girder is called as a stiffening girder. So these are the different terms which is used in case of the suspension bridges. Okay, so next, that is a structural analysis of your suspension bridge. Okay, structural analysis of the suspension bridge. So the main force, as I told, the main force in case of suspension bridge or in case of suspension cables, nothing but the tension, because cable is one of the type of tension member which is predominant to carry the tension, Okay, so main force in the suspension bridge are the tension in the main cables. Okay, tension in the main cables and compression in the pillar, because pillar or vertical element that is called as pylon or the tower, these are nothing but acting like a column. So column is nothing but the compression member. So pillars is also considered as a compression member. So main forces in the cable is your tension, and in case of pillar or the tower, that is vertical support, that is carried by the compression. Okay, so it is almost like the same like a column. Okay, on the column is vertically downwards and they are also stabilized by the main cables. Okay, suspension cable. Okay, then in case of the suspended deck bridge, okay, cables suspended via towers hold the up the road deck. This is your road deck, vertical elements tower, vertical elements tower. This is suspension cable, anchorage cable. Okay. So in case of suspended deck bridge, so cables suspended via towers, these vertical towers, hold the road deck slab, road deck slab. Okay. The weight is transferred. The weight is transferred by the cables to the towers. Okay, whatever the weight is there, that will be transferred by the cables to the towers. Okay, which in turn transfer the weight to the ground through the anchor cable. Because here somewhere we are anchoring, here somewhere below the tower there is a foundation. So whatever the weight which is by the cable which is carried, that will be transferred through the piles, sorry, through the pillars or through the pylons, okay, to the foundation, and foundation to the ground, right? So most of the weight or the load of the bridges, most of the weight or the load of the bridge is transferred by the cables to the anchorage system, to the anchorage system. Okay, so these are embedded in either solid rock. Okay, as I told, this is a rock, or you can consider as a foundation, okay, or the concrete. So these are embedded in either solid rock or the concrete blocks. So inside the anchorage, the cables are spread over the wider area, okay, over the wider area, over the wider area, to evenly distribute the load and prevent the cables from breaking free. ठीक आहे, इकडच्या जे साईडला जे तुमचे अँकर केबल्स असतील, ओके, so they are spread over the larger or the wider area, okay, to prevent the cables from breaking free, right? To prevent the cables from the breaking free. So these are the some important points regarding structural analysis of the elements of the suspension bridge. Okay, main is the force which is carried by the cable is tension, and the load which is carried by the pillars is compression. Okay, so whatever the load which is carried by the pillars, that will be transferred to the foundation, right? Then in case of suspension bridges, so whatever the cables are there, that is suspended through the towers, which will hold up the deck slab. So whatever the weight which is transferred by the cables to the towers, okay, and then it will be transferred to the ground. So most of the load or the weight of the bridge is transferred by the cables to the anchorage system, and then it is to the solid rock or to the concrete block. Okay, and whatever the anchorage or the anchor cables are there, that will be spread over the larger area to prevent the breaking of the cables, right? Then what is the structural failure of the suspension bridges? Okay, if you see, if you can see, these are the cables which is under tension, or whichever the cables are there, suspension cable or the anchorage cables, they are carried by the tension, and whatever the towers or the pillars are there, they are under in a compression. They are under in a compression, right? So this is again cables under tension. Whatever the suspension cables are there, cables under tension. Then these anchor cables are under tension. These anchor cables are under tension. Okay, anchorages are under tension, and then these pillars are under in a compression. Okay, so whatever the load of the cables which is carried, okay, from the deck slab through the suspender, that will be transferred to the pillar, okay, like a compression force, and then it will be transferred to the foundation. Similar way, whatever the tension is there, that will be carried by the pillars, okay, and then it will be transferred to the foundation, right? This is at the end or at the side. The next, structural failure. So in case of suspension bridges, some bridges which have in the past suffered from structural failure due to combination of poor design and several weather conditions. Okay, because if wind blow is pressure is maximum, or due to the cyclone, etc., due to that also the bridge may be fell. Okay, due to the poor design or due to the severe weather condition. That is nothing but the, it may be cyclone or it may be severe earthquake. So collapse of the bridge also depends upon the phenomena called resonance. Okay, repetitive loading. So it is the phenomena when the body vibrates at its natural frequency and it shatters, right? So this is one of the reason for the failure of the bridges. To avoid this type of failure, okay, so we will use the new bridge prototypes which have been tested in the wind tunnel before being constructed. So in the past, if you see through the or you can search, then maximum bridges, suspension bridges, example is Tokomo Bridge. Example is Tokomo Bridge that will collapse due to the heavy wind pressure or heavy wind, right? So nowadays, whatever the bridge prototype is there or the model is there, that is tested in the lab, okay, under the wind pressure or in wind tunnel, okay, before being constructed. Okay. So this is regarding just introduction part of your suspension bridges. Wait 1 minute. One minute. Screen is visible.
Yes, sir.
Right. So these are the main elements. Now we will discuss about the finding out the tensile force in that particular suspension cables, then shape of cables, etc. So if you see this suspension cable, this is your deck slab which is subjected by the load in terms of UDL, that is WKN per meter. Then this is at the end, that is you may call as tower, okay, or you can take the span point A and point B, okay. So at this particular point, so this cable is subjected by the tensile force. This cable is subjected by the tensile force, okay. This cable is subjected by the tensile force like this. This is your tension, this is your tension, right? They are subjected by the tension. So if we resolve this tensile force in two components, vertical and horizontal, suppose it is inclined, T, that is tension which is inclined. So we have to resolve this in horizontal and vertical component. Okay, so W is nothing but the UDL which is on the deck slab. Okay, and these are the suspenders, vertical suspenders which will carry the loads, right? So now we will find out the reactions, horizontal reaction. So if you refer this diagram, okay, UDL, span is suppose small l is there, right? Small l, W is UDL. So vertical reaction VA, vertical reaction VB, horizontal reaction H. Okay, so we will now find out the reactions, vertical and the horizontal reaction. Okay, so for equation for the horizontal reaction, taking the moment about point C on the right side. Okay, so reaction, vertical reaction, okay, UDL is there, W, span is your L, so it is VL by 2, that is nothing but the vertical reaction by taking summation of Fy. Okay, now taking the moment, okay, this is your vertical distance, that is D, that is called as a sag, that is called as a sag, right? Horizontal reaction, right? And the UDL is there, W span is your L. Okay, so this is your H. So if you consider the right side part, okay, so by taking the moment about this point, so H into D plus WL square by 8 is equal to, this is your VA, this is your L by 2, this is your L by 2, right? So H into D plus half UDL, right? W L square by 8 is equal to, okay, हा दोन्ही काय करणार आहे तुमचे असे मोमेंट क्रिएट करेल, H इंटू डी असेल आणि हा UDLचा आणि हा अपोजिट डायरेक्शनने असेल. ओके, सो इट इज इक्वल टू घेतलेला आहे W into L by 2, that is nothing but the VA or VB multiplied by the span is L by 2, right? Multiply by span into L by 2. So H into D plus WL square by 8 is equal to WL square by 4. So horizontal reaction H we get is equal to WL square by 8 times D, where D is nothing but the sag. Okay, from this up to the distance, that is vertical distance, that is called as a sag, that is small d, right? So after the simplifying, you get horizontal reaction H is equal to WL square by 8D. Understood? Yes or no?
Yes.
All right. So you get the now the vertical reaction and the horizontal reaction. Okay. VA, VB, vertical reaction and horizontal reaction, use your H. Now, after the calculating the reactions, horizontal and vertical reaction, now we will find out the tension in the cable at the end. Okay, tension in the cable at the end. So this is horizontal reaction, vertical reaction is suppose VB, right? And some point we have taken, that is suppose P point is taken, UDL is W, so T is there. So what will be the tension in the cable at the end, that now we will find out. So the cable tension capital T at any end is the resultant of vertical and horizontal reaction at the end, right? मी आताच काय म्हणलं होतं, हा टेन्शन फोर्स होता, याचे दोन कॉम्पोनंट आहेत, एक हॉरिझॉन्टल आहे, दुसरा वर्टिकल आहे. मग आपण रिझल्टंट इज इक्वल टू काय करतो, स्क्वेअर रूट ऑफ समेशन एफ एक्स स्क्वेअर प्लस समेशन ऑफ एफ वाय स्क्वेअर, किंवा मग काय असतं स्क्वेअर रूट ऑफ एच एस स्क्वेअर प्लस व्ही स्क्वेअर, बरोबर ना?
Yes.
Right. So at A, at B, tension at A and at B is equal to T is equal to square root of A म्हणजे तुमचं VA आहे आणि हे म्हणजे तुमची H आहे. So VA square plus H square. Okay, that is your resultant. That is nothing but tension. So after simplifying, T is equal to, okay, so WL square by 2, sorry, WL by 2 bracket square plus याला स्प्लिट केलं ब्रॅकेटला, ओके, तर हे डब्ल्यू स्क्वेअर, हे सॉरी एल स्क्वेअर आहे, ब्रॅकेटचं स्क्वेअर पण आहे इथे, ओके, डब्ल्यू एल स्क्वेअर इंटू स्क्वेअर दॅट इज डब्ल्यू स्क्वेअर एल 4 divided by 64 d square, that is the expansion of this bracket, plus WL by 2 bracket square. So WL by 2 taken common. So T is equal to 1, T is equal to WL by 2 square root of 1 plus L square. L is the span. Okay. Divided by 16 times D square. So that is the tension in case of the cable, right? So T is equal to W L by 2 square root of 1 plus L square by 16 D square. That is the value of your tension in the cable, right? लक्षात आलं?
Yes.
H is horizontal reaction, VA vertical, and T is the resultant as per the diagram. So T is we get as a tension in the cable, right? So as you know, the resolution of the forces, right? So T is the tension at any point P of the cable, as you can see in the previous diagram also. In this diagram, at point P, okay, this is point P, and theta is the inclination of the tangent at P, means where wait, if you consider this is angle theta, okay, this angle is your theta, right? So theta is the inclination of tangent at P with horizontal, considering the equilibrium part of PB. So resolving the forces on this part, okay, at T है, horizontal reaction आहे, suppose theta आहे, हा H आहे, जर तुम्ही असा घेतला, सॉरी, हा T आहे, horizontal H आहे, हा theta घेतला तर resolution H is equal to T cos theta. Okay, so this is your H is equal to T cos theta after resolving. So minimum tension in the cable will occur at C. Okay, that is nothing but T minimum at C is equal to H at this point, that is C. So minimum tension in the cable occur at this point. So it's nothing but your T minimum, that is your H. And the maximum tension will be occur at the support or at the ends. Maximum tension in the cable will occur at the ends where there is the pillars or the support is there or where is the towers are there. So this already value we have calculated. T max, that is nothing but square root of h square plus v square. So this is your T max. So beta angle is with respect to vertical. So this is your tension. Okay, this with respect to the vertical, that is beta. Okay, so is equal to h by v. Okay, beta. So tan beta is equal to समोरची बाजू भागिले लगतची बाजू. So opposite side divided by adjacent side. So opposite side is your nothing but the horizontal force. Adjacent side is nothing but the V. So tan beta is equal to h by v is equal to, by putting the value of h and v, you get tan beta is equal to L upon 4 times D. Right? So these are the values of your horizontal reaction, vertical reaction, then tension in the cable, maximum tension, minimum tension, right? And then the value of the angle beta with respect to vertical. Okay, with respect to the vertical. Understood, all of you? लक्षात आलं?
Yes, sir.
Okay, so please write down fast. Main elements, only write down the names. Write down the names. जय प्रथमेश,
Yes, sir.
आता तुम्ही मोबाईलवर अटेंड करताय का लॅपटॉपवर अटेंड करताय?
मोबाईल असतो.
ओके, ठीक आहे, चालेल, ठीक आहे, ठीक आहे. लिहिलात का नाव लिहिलात?
Yes, sir.
ओके. Next, draw this diagram. Show the point C somewhere. Vertical distance is your small d and span L. This angle is beta with respect to vertical. Please draw this diagram. Diagram is over.
Yes, sir.
Okay. Then write on this. Equation of horizontal reaction. Taking the moment about C on the right side of C. Or
Yes, sir.
right. Next, cable tension at the end. This is your beta. This is suppose VB. This angle is theta. W. Please write down the heading and write down the heading and draw the diagram. Cable tension at the ends. Okay, shall I proceed?
Oh, wait, sir. Yes, sir.
Okay. And around tension in the cable tension capital T, that is resultant square root of HS square plus VS square. So you get the value of T, that is tension in the cable. Done? Okay. Shall I proceed now? Shall I proceed?
Yes, sir.
Okay.
Yes, sir.
The next.
Wait.
Then on this tension at the point P, as per the diagram of the cable, theta is the inclination of the tangent at P, resolving force horizontal component resultant into cos theta. So minimum tension in the cable will occur at point C, that is nothing but H. After resolving at point C, there is tension which is horizontal to the left and horizontal reaction to the right. They are balancing, so that's why it is equal. Okay, and at the support it is maximum. So it is maximum at support, that is nothing but taking the or calculating the resultant, that is square root of hs square plus vs square, you get the maximum value at support and minimum at the center, that is tension towards left and H is acting towards right if you consider left part or if you consider the right part. So that will be balanced, horizontal will be balanced. At support, it will be maximum. Okay, done? Proceed?
Yes. Yes, sir.
Right. Next. Maximum tension in the cable will occur at the ends. So that value already we have calculated. And beta, with respect to vertical, tan beta is H by V. Or done?
Yes, sir.
Yes.
Right, okay. So today we will stop here. So remaining part, that is shape of cable, length of cable, then anchor cables, etc. So derivation of this we will discuss in next class and we will take the numericals on this. Right? So near about it
Okay,
is concept of your 2-inch or the 3-inch arch. Okay, 2-inch or the 3-inch arch concept is there. Okay, parabolic concept is there. So by using that concept and the applied mechanics knowledge, we will derive some equations or we will derive some formulas and we will take the numericals, right? Okay. I will take attendance. ते प्रोग्राम एक चालू आहे वाटतं ना, ते अटेंड करा.
yes, sir.
काल काळे सरांनी टाकलं होतं ना,
आज आहे का सर ते?
आज आहे बहुतेक ते तुमचे सिनियर्स अटेंड करतायत, ते लिंक टाकले होतं ना,
ओके. हो सर.
ते अटेंड करताना फोटो काढा आणि ग्रुपवरच टाका. तो एमटेकचा ग्रुप आहे,
चालेल.
तिथे टाका. जय, रोल नंबर 8, प्रथमेश. 10 आहे ना?
7 सर.
7. सौरभचा 10 आहे का?
5 वाटतं सर.
5 आहे का?
5 आहे सर. हा 5 आहे.
अच्छा, जीनतचा 4 आहे.
Yes, sir.
राईट. 4, 5, 7, 8. ठीक आहे. काल मेल भेटला ना?
हो सर. हो हाल.
ठीक आहे, चालेल. चलो, shall I close now?
Yes.
Yes, sir.
Thank you.